Indirect collisions, type 2, one sphere is at rest and the line of centre is through the j directions, so therefore I is going to be conserved in this question. So in 2009 we have two spheres, both with equal mass, colliding, and we have the second one is stationary at rest, and we're given the fact that the direction of motion of A before impact makes an angle of alpha with the lines of centre at impact and just touches the sphere B as shown in the diagram. This time we're given our coefficient of restitution, so in other words E is going to be 4/5, and the first thing we want to do is show that the angle alpha, the angle it makes with the direction of motion before impact, is 30 degrees. So if we have a little closer look at this diagram here, the fact that we're told that the line of centres at impact, the direction of motion just touches sphere B, well, basically in that diagram we can see that that is a tangent, okay? So if I mark in the centre of sphere B there with the red dot, well, from the centre to the tangent must be the radius, and therefore we know that that must be making an angle of 90 degrees because a tangent and the radius will be 90-degree angle. So let me just take that diagram out. So on impact, the centres are going to be collinear, and the angle then is going to be 90 degrees because it's a tangent, and this here then is alpha, and alpha is what we are trying to find. Now if I go back to the diagram there in the question, well, that's the radius of sphere B and the radius of sphere A. Now we're told that these are identical. Look in the question, they are identical smooth spheres. So that means they're identical in every way. They're identical in size, they're identical in mass. So therefore they both have the same radiuses. So in other words, the distance between the centres must be 2, or if I mark that on my triangle, and then the distance from the centre of sphere B to the tangent, the direction of motion of sphere A, well, that must be the radius also. So now what I have here on my diagram, if I mark it in, is I have the opposite and I have the hypotenuse. And therefore, if I have the opposite and the hypotenuse, well, my ratio must be sine. In other words, sine alpha is equal to the opposite over the hypotenuse. And if sine alpha is equal to the opposite over the hypotenuse, well, that means that sine alpha must equal or over 2 or, which is great, because now all of a sudden we don't have any ors anymore because they cancel, leaving me with sine alpha equals a half. And of course, if we go to page 13 of our maths tables and get sine inverse of a half, or you're using your calculator, making sure your calculator's in degrees, because the question here is show that alpha equals 30 degrees, then we'll find that when we get sine inverse of a half, we actually do get 30. So a lovely, nice little start to that question there. Good bit of understanding there from your maths as well, okay? So there was only 5 marks going for that part of the question. So even if you couldn't get the first part out, you still know what alpha is for the rest of the question. So part 2 then wants us to find the direction in which each sphere travels after the collision. So we're looking for the direction of the spheres, which means that we need to know their angle. So we need to work out their slopes. In other words, we need to look at tan after the collisions. So to find the direction after the collisions, we obviously need to set up our table, do our principle of conservation of momentum, Newton's experimental law of restitution, and work out what their speeds are after the collision. So let's start by making out our table on the next page. So to make our table, we have to look at the diagram that's been given to us, and we have to be careful to note that the line of centres is in the j direction this time. And also that we haven't been given the direction beforehand for A, we're only being given the direction there afterwards. So if we go and we draw a diagram next to our table before we complete the table out, we can see that this is the direction afterwards. So if I come back, where does it appear to have come from? means that that's u there. And therefore, if I resolve that vector into its I and its j components, we're going to have our I, and we're going to have our j. And of course, we have vertically opposite angles there, so that's going to be 30 degrees there, making this the opposite, and there's 90, so this would be the adjacent. So in other words, this is going to be u sine alpha, and this is going to be u cos alpha. So your u cos alpha is your j direction, and your u sine alpha is your I direction. So normally we would say that u is equal to u cos alpha I plus u sine alpha j, but in this case, from this diagram, the lines of center being through the j direction, we actually end up with u sine alpha in the I direction and u cos alpha in the j direction. So you just have to be careful with that. So how many of you actually got caught out with that when completing out your table? So in other words, u is, again, if we look at the diagram here, it's actually going in the negative direction. So that's going to be minus u, and sine alpha, we've said, is a half because that's sine 30. So that's going to be minus u over 2i. And then we have a positive direction for the j, and cos 30 is going to be root 3 over 2. So that's going to be root 3u over 2 in the j direction. So cos 30 is equal to root 3 over 2, and sine 30 is equal to a half. Okay? All right, so filling out our tables then, well, what can we say? So if I just label my spheres so that we have easily recognizable from the table, what am I referring to? So A, we've said there that its velocity beforehand is minus u over 2 in the I direction plus root 3u over 2 in the j direction. Identical masses. So therefore afterwards, because of the lines of center in the j direction, that means that j is going to change and I will be conserved. So therefore minus u over 2i. And we don't know what its new velocity is going to be in the j direction, so that's going to be pj. And the second one, b, is at rest, so that means it has no velocity in the I and no velocity in the j, and therefore afterwards it will still have no velocity in the I, because that's going to be conserved. In other words, it will only move off in the j direction because it was at rest. So if you think about anything, if it's coming in, it's moving off, it's literally going to bang and shoot off at the top, if you've ever played snooker before. Okay, so what are we going to do? Well, we do the same as we always do. We start off with our principle of conservation of momentum. m1u1 plus m2u2 is equal to m1v1 plus m2v2. And if I'm subbing in my values, then that's going to be m times root 3 over 2u plus m times 0 is equal to m times p plus m times q. And again, our m is gone all the way across, and that simplifies down to give us p plus q is equal to root 3u over 2. So that's our first equation. Second thing we want then is our Newton's experimental law of restitution. So again, we go to page 51 in our tables for that. And we have v1 minus v2 equals minus e times u1 minus u2. So that gives us p minus q is equal to minus e times root 3 over 2u minus 0. But of course we know that E is equal to 4/5. So that becomes P minus Q is equal to minus 4 root 3 U over 4. Sorry, not 4, over 2 times 5, which is 10. Sorry. So if I simplify that down, I can multiply across. So 4, that'll become 2 over 5. So if I multiply across by 5p minus 5q equals minus 2 root 3u. So I have my second equation. Okay, so I'm going to multiply the first equation there by 5 and set up my simultaneous equations on the next page. So we're going to have 5p plus 5q is equal to 5p, so 5 root 3 u over 2. And the second equation there then is 5p minus 5q equals minus 2 root 3 u. So my 5q's are gone, so that leaves me with 10p is equal to root 3 over 2u. And then p must be equal to root 3u over 20. So to find q then, I'm going to sub p into 1. So if I sub p into 1, that's p plus q, so root 3u over 20 plus q is equal to root 3u over 2. And then if I take those to one side, I have root 3u over 2 minus root 3u over 20. So lowest common denominator there is 20, which then gives me 9 root 3u over 20. Okay, so now we have P and Q. I can say, well, after, I called the two spheres A and B. So after the velocity of the first one, it's going to be minus u over 2 in the I direction, plus root 3u over 20 in the J direction. And the velocity of the second one then is at rest in the I direction, so it only has velocity in the J. So 9 root 3u over 20j. Okay, so now we have their velocities. What is it we are looking for again? We go back to the question and it says find the direction. Okay, so we have to find the direction in which the speeds travel, which means I need to work out their slopes. So on the next page we'll say direction. So for A, our direction can be found by getting our tan of our angle, in other words our slope, and our tan, remember, is going to be our j over our I. So our j is root 3u over 20 divided by u over 2. So we have root 3u over 20 divided by u over 2. So the u's cancel, and that leaves me with tan alpha is equal to root 3 over 10. So if I get tan inverse root 3 over 10, well, that gives me 9.83 degrees. And of course, that's going to be going in west and then north because we had a negative u over 2. And then if we do the same for B, well, that's going to be tan beta. And therefore, it's obvious when we look at that one, it's literally only got a j direction. And therefore, its direction must be north. Okay? So, of course, direction is north, or you can say along the line of centers. Okay, now there was a lot of work in that, but it was straightforward enough. So really there was only 5 marks going for the directions and 5 marks going for both of the equations. So for equation 1 and equation 2, you were getting 5 marks. That was 15 marks. So would you believe this was only an actual 20-mark question? And yet we still haven't finished it. We have a third part to go, where we have to work out the percentage of kinetic energy lost. Now, if we're looking for kinetic energy lost, we need to get kinetic energy beforehand. minus the kinetic energy after. So collisions generally are straightforward questions because you're just doing the same thing again and again and again from year in, year on out. But it can be time consuming, so you just need to make sure that you're kind of efficient in how you're doing out these questions. So again, you can work out your kinetic energy lost all in one go and then get your percentage loss by putting it over the original. But of course, because this is a solution video, I'm going to break it down into kinetic energy before and kinetic energy afterwards, and then kinetic energy lost. So our kinetic energy beforehand is going to just simply be a half mu squared. Because obviously the second sphere B is at rest, so it doesn't have any kinetic energy. So we'll just say B is at rest. Therefore, the kinetic energy is 0. And then if we're looking for our kinetic energy after, well, then that kinetic energy must be a half m and then u squared. And of course, well, we have to work that out to the side. Okay, so again, our magnitude is our a squared plus our b squared. So of course, what did we have for the velocity after? For sphere A, well, we had the square root of u over 2 to be squared plus p, which was root 3u over 20 to be squared. So of course that velocity, the magnitude, is going to be the square root of u squared over 4 plus 3u squared over 400. And that simplifies down then to give us the square root of 103u squared over 400. Okay, so if I put that in here, well, if I square that, it's clearly just going to get rid of the square root sign. So that's 103u squared over 400. And so that's for sphere A. And then if I do for sphere B, well, it does have velocity afterwards. And that was q, because obviously in the I direction it's 0. So it's going to be 9 root 3. So was that, 9 root 3 u over 20, and then I have to square that. So if I simplify my kinetic energy after, that's a half m, I'll do that again. That's going to be m, 103 u squared over 800 plus 243 mu squared, and then that's over 800 as well. So if I combine those two together, we end up with 346 mu squared over 800, and then 346 over 800 can be simplified down to 173 mu squared all over 400. Okay, so that's our kinetic energy after. So therefore, if we're looking for our kinetic energy lost and we're looking for the percentage kinetic energy lost, well, the percentage kinetic energy lost is going to be the difference between the two. So it's our before minus our after. And that's all over before. And I'm going to multiply that by 100. So of course that simplifies down then. The mu squareds are all going to be gone there. And that leaves us then with 27 over 200 times 100, which is equal to 13.5% kinetic energy lost. And there was 5 marks going for that. Okay, so as I said, you can make that much shorter by doing it all in one go to get your 5 marks. But, you know, you can see there's quite a bit of work in there, straightforward work, but 20 marks all the same. Okay, so A was given 30 marks that year.